Okay, so for our classwork, if we click on this, hopefully I can make this bigger. We're solving inequalities involving absolute value. So that could be the title of your notes. It's actually 913. So let's see if I can, make this bigger. Oh yes, thank you. Well, and then it wants to freak out when I try to do anything on it. Okay. Okay, can you guys see that on your screen? Hopefully you can. Can somebody? Oh my gosh, what happened? Okay, I should have just done it. You know what? Let me do a screenshot. I'm going to pause this for a second. All right, so the title of these notes, let's make the title 913. Let me get my pen here. Okay. I don't have room for a title. 9.1.3, solving inequalities, and that says 913. Solving inequalities with absolute values. Absolute values. Okay, if you remember absolute values, right, guys? Let's say if we have the absolute, say we have an absolute value of x is greater than 3. Okay, remember absolute value is the distance that something is from 0. Right, that's what absolute value is. Absolute value is how far is a number from 0. So if I had said, hey, the absolute value of x equals 3, if I put equals instead of greater than, what number has a distance 3 units away from 0? Or numbers, is there more than one answer? How many numbers have a distance 3 units away from 0, guys?
It's 3 and -3, so there's 2.
Okay, so good. Positive 3, good. Is 3 units, is 1, 2, 3, has a distance of 3 away. And then we could go the other direction, 1, 2, 3, over here, 1, 2, 3, at -3. So there are 2 answers whenever you have absolute value, right? That's why you have 2 answers. So x in this case is equal to positive 3 and -3. We have 2 answers whenever you do an absolute value, 2 answers. Okay, and people that's the most common mistake, is people only give me 1 answer when we do an absolute value problem. I think we had these on your standards quizzes at the beginning of the year, and a lot of people gave me 1 answer. Pretty sure we did. So how are we going to get, so what if we throw an inequality sign in there? If we throw a greater than sign or a less than sign, you know, what if I had like absolute value of y is less than 5? Okay, this means, hey, the distance between 0 and the number is less than 5. Well, so let's do this. Let's graph this one. I gotta move this thing out of my way. There's all these bars in the way. Okay, so what numbers have a distance bigger than, no, less than 5 from 0? Right, 2, 3, 4, 5. So if I go -5 right here, I go 5 this way, 1, 2, 3, 4, 5, 5 that way. Which numbers have a distance less than 5? Well, that would, and here's 0, right? So that would be all the numbers in between -5 and 5. Does that make sense? And we shade all the numbers in between. So 0 is less than 5 units away from 0. 1, -2, -3, -4, all have a distance less than 5 units away. Do we include -5 in this answer? No, it's empty, right? It's an empty circle because we're not including it because it's just a less than sign. If it was an equal to underneath there, then I would fill it in, right? But it's not, so let me undo that. Okay, so what about greater than 3? What if x is greater than 3? So hopefully you wrote that down. If you didn't write that down, what numbers have a distance bigger than 3 units from 0? 1, 2, 3. So, so here's 3. So if it's bigger than 3, I'm going to shade away from the 0, right? Because these numbers are more, this is 4, 5, 6 units away. These have more distance from 0. And then I also go 3 the other way, 1, 2, 3 to -3. And I put an open circle and I shade away from the 0 because -4, -5, -6, those all have distances bigger than 3, right? So here, when you have greater than, your shading is going to go away from each other. Okay, so it's always going to be, if it's greater than, it's always going to be away from each other. Okay, so we can write that in your notes. Greater than, like this symbol or this symbol, right? If it's greater than or equal to, then we just fill in the circles, right? So they're going to go away from each other. Shade away from each other. Kind of jumping ahead of where we need to be, but less than is always going to be like this, right? So when it's less than or equal to, your circles are always, your shading is always going to be in between the two circles. Okay, whenever you have less than or equal to. Now, let me tell you, sometimes you're going to flip these signs within a problem. Like for this problem, we're going to end up flipping the sign. And so it's going to change from less than to greater than or equal to. So that's going to change our shading. But that's because there's a minus in front. But again, I'm jumping ahead of myself. So far we have this in our notes, right? I need to erase this, guys, so we can do some of these problems together. Okay. So let me move this bar out of the way. There we go. I don't need the Cami sign. Okay, so let's solve this. Number 1. Okay, so write this on your paper. Number 1, absolute value of 6 times k is greater than 6. So there's some number that we multiply by 6 and we take the absolute value of. What happens to numbers you take the absolute value of, guys?
6k.
Right, but do they become positive or negative?
Both.
So if I have a -6 in front of here, let's say k is -1, right? I'm going to make k -1. And so I have a -6 in here. What is the value of the absolute value of -6?
Yeah, 6.
6, right? So absolute values changes any value inside to positive numbers. So if there's a negative in there, it becomes positive. If there's a positive in there, let's say k was +1, right? If I made k 1, then I'd have 6 times 1, and I'd have absolute value of 6. Well, that's just 6, right? So any value inside the absolute value becomes positive after you do the multiplication. You have to do everything inside first, though, before you take the absolute value. You don't take the absolute value of that -1. Notice I multiplied these first. 6 times -1 is -6. And then you take the absolute value, which becomes +6. Okay, so that's just like a little review. Okay, so how are we going to do this problem? Let me erase this stuff. This is extra stuff we don't need. Okay, so what we need to do is, since it's a greater than problem, okay, this is how you do all greater than problems. You have to make or in there, okay? If you have a greater than, that is an or problem. If you have a less than, that is an and problem. Okay, you either have and or. This is a greater than. There's or because we're going to have two situations. We're going to take this inequality and we're going to do what I call flip and switch. You only do this with greater than problems, okay? Flip and switch. Okay, what does flip and switch mean? It means you're going to flip this inequality to make it a less than. So 6k is less than, and you're going to switch the sign on this. Instead of +6, it's -6. Okay, why do we do that? Because it just works remember how we did like this half? Now we have to do this half, the negative side. So you have to make that negative. That's why you have to do that. Okay, so now we're going to solve both of these. This one I can drop the inequality sign. So I'm going to pretend here, I'm going to erase the absolute value sign. I'm going to erase that. Okay, because this is the first one. You just do it like normal. That's what everybody does. Everybody knows how to do this part, but they forget to do this part, the flip and switch part. So Let's divide by 6 now, just like it's an equal sign, right? If this was 6k equals 6, we just divide by 6. So we're going to divide by 6, and we're going to get k is greater than 1. Or that's 1/2 of the graph, right? Or we have this half of the graph. We're going to divide by 6, or k is less than -6 divided by 6 is -1. So we have two inequalities, which we call a compound inequality. Okay, all your answers should be compound inequalities. Have you heard of compound sentences, guys, in English class? A compound sentence has and or but in it, but we don't have any buts in math. It's and or. This one has an or because it's greater than. So this is a compound inequality because really there's two inequalities. So we're going to graph the two inequalities on here. So k is greater than 1. So I'm going to put an open circle at 1. And colors are helpful. So if you have colored pencils, yay. And I'm either going to shade to the right or to the left. Well, since it's greater than, it means I shade to the right of 1. Okay. Then I'm going to do the other half. K is less than -1. So I'm going to put an open circle at -1. And I'm going to shade to the left of -1. And make sure you make that arrow at the end to show that it goes on forever, to -infinity, to positive infinity. It goes on forever. 6, 7, 8, 9, 7, 8, 9, ... forever to infinity, right? Same thing on this side, to -infinity. So look at our graph. They're going away from each other. Okay, away from each other. Why is it going away from each other? Because it's a greater than problems. All greater than problems will go away from each other unless you end up flipping the sign, which we will later down here. Okay, so that's a greater than problem. This is a greater than problem, so I'm going to skip that one. Let's go on to number 3 because it's a less than problem. So I'm going to change my color here. Let's go to number 3. Okay, so you want to copy down number 3. It's a less than problem. So since it's less than, I'm going to copy down 4 plus n is less than or equal to 5. And it has absolute value bars here, right? It has absolute value of 4 plus n. But, so this is how you do all less than problems. Because this is a less than symbol, right? Less than or equal to. So we do it different than the last problem because the other problem was greater than. So, I'm going to erase the absolute values, and instead of flipping and switching, this is what we do. We're going to get my pen back. We're going to put this symbol on the other side. Okay, so whatever this symbol is, you just duplicate it over here. And then instead of the +5, I make a -5 over here. So it's kind of like flipping and switching, but that's what you always do. You put the same symbol over here, and you put this number over here, but you make it negative. Okay, and now we're going to solve this for n. So in order to solve this, I would -4 from the middle. I'm going to -4 to the left side, and I'm going to -4 to the right side. So you're doing it 3 times, to the middle, the left, and the right. Okay. And that's going to get rid of that 4, and I'm going to have n is greater than or equal to. When I read it this way, it's greater than or equal to -5 minus -4 is -9, and n is less than or equal to 5 minus 4, which is 1. So now we have gotten the n by itself, and we have this compound inequality, right? This is a compound inequality here. And how do we graph this? Well, it's just going to be, it should be 2 circles shading towards each other. So let's go to -9. I'm going to put a closed circle because it's equal to. So at -9, we put a closed circle there at -9. And then at 1, way over here, I'm also going to put a closed circle because it's less than or equal to. So we're including 1 in our solution. And then we're going to shade towards both circles, in between both of the circles. Why? Because the distance is less than, let's say 4 units away or whatever from, oh, we shifted over to 4. So now the middle is no longer 0. The middle is like over here. So we're like doing this many units away from here, this many units away from here, because we did the +4. Okay, so it's 5 units away from here. It's 5 units away from here. Okay, so that's how you do a less than problem. All right, does that make sense? Okay, let's try another greater than problem. We'll do number 4. Go ahead and copy number 4. Am I going to do and or for this problem, guys?
Or.
Copy the problem as is. X minus 7 is greater than 3. And since it's greater than, I'm going to do or. My second equation is going to be separate. Or x minus 7 is, what do I have to put for the rest, guys? Less than -3. I have to flip this sign and make this negative. Okay, flip and switch. So I flipped the greater than, made it less than, and then put that negative. Okay, so now let's solve it. So to solve this, we're going to add 7 to both sides, add 7 like that. We get x is greater than 3 plus 7 is 10, or then we're going to add 7 here, add 7 here, x is less than 4. So we have 2 answers. X is greater than 10, so at 10 we're going to put an open circle and shade to the right because it's greater than. And then at 4 we're going to put an open circle and we're going to shade to the left because it's less than 4. So these are all the numbers that have a from 7, or have a distance greater than 3. 1, 2, 3. 1, 2, 3 is what that means. Okay, so that's why our shading is like it is. Okay, I want to do a problem like number 6 with you, but I made 2 of my own. So I'm going to erase this and start a new screen. So let me do that. You guys with me? And actually, I need to get out of here. Escape. Whoa. And go back to that screen. I need an empty screen. Empty screen, let's do that. Okay, so the 2 examples that I have for you are not on that paper. These ones are a little bit more difficult. So where's my pen? There we go. So this first example, so a little bit more difficult example here. Let's say we have -50. -50 is less than or equal to, oh, I'm sorry, I take that back. So I can take that back. It is the absolute value of 3 minus 5n is less than or equal to 50. Okay, so normally this is a less than problem. So normally, and it's got less than or equal to. So normally it would go like this, right? The shading would be in between, but let's see if that's the case for this problem. Let's solve it. Since it's a less than, what we do is we take this symbol and you put the less than sign over here. And then with the 50, I put -50 over here. And then I solve it. And then I'm going to ignore these absolute values, right? So to solve 3 minus 5n, I would -3 from the middle, -3 from the left, -3 from the right. Giving me, this goes away. So I still have -5n here is greater than or equal to. When you read this direction, you read it backwards. So this means -5n is greater than or equal to -53. Okay, which is less than or equal to 50 minus 3 is 47. Okay. Now we're going to do something that we talked about the other day. We're going to divide by -5, divide by -5, divide by -5. What very important thing happens when you divide by a negative? What do you have to do?
Flip the sign.
Good, you have to flip the sign, which I just didn't do, huh? And I need to do that. got ahead of myself. So yeah, we have to flip this sign and we have to flip this sign. Why? Because we're dividing by a negative. So just switch it the other way. I don't care really what it is. I'm just going to flip that one and flip that one. Okay, so n is now less than or equal to 53/3. That's like 10 and 1/3, right? 10 and 1/3, or 2/3. 10 and 2/3. 10 and my brain is not working mathematically right now. It is 10.6. So 10 and 2/3. No, yeah, 2/3. Not 2/3. It's 10 and 6/10. Okay, let me. I need to erase that. 10.6. So get my pen back. It's 10.6. And then do 47 divided by 5 in your calculator. We get 9.4, negative 9.4. Okay. Okay, now take a look at this. Normally I would say, okay, oh, this is great. This is our answer. We got a number, blah, blah, blah. But there's something very bad about the way that this is written. And that is these numbers. Does anybody know what's wrong with this? The lower number should always be on the left and the bigger number should be on the right. So the bigger number should go on the right. Well, we all know that 10.6 is bigger than negative 9.4. So we're going to switch these around. I'm going to put negative 9.4 and 10.6. I'm going to switch them around. I'm going to leave the n in the middle. But if I switch these two, we talked about this a little bit last class period. What do I have to do to my inequality?
You have to flip the sign again.
Right, I have to flip both of these again, right? And yeah, we did it once, and look, we had to do it twice. Now this is in the right form because you always want the lower number on the left and the bigger number on the right. And if it comes out like this, where the bigger number's on the left, the lower number's on the right, if you leave it like that, I will take off a point. You'll get most of the points for this work that you show, but I will take off a point if you leave it like this, because this is going to help you graph it better. So let's graph this. Let's make like a little number line, right? Boom. Oh, I should have used the arrow tool. Is there an arrow tool? Yeah. Go like that. Boom. Nice arrows. Look at that. Fancy. And then I'm going to put negative 9.4 over here, or put negative 10, negative 9, 0 somewhere in the middle. And then this is 10.6. So I'll put 10 over here and 11 over here, right? So negative 9.4. And it's less than or equal to, so we'll put a closed circle, like halfway in between, and then an opens another closed circle at 10.6, which is a little bit further than halfway in between. And since it's greater than this, I'll go this way, and less than this, I'll go the other way. It should be shading towards each other. Okay, so the shading is towards, again, colored pencils, guys, highlighters, use color for this, all right? I always use lots of colors on my notes, and hopefully you're gonna use colors on your homework when you submit it. So this was a less than, but then we ended up flipping it because of the negative out in front. We ended up flipping the sign, but then we flipped it back because we flipped it again. So we had to flip the sign twice, right? So a little bit complicated there. Okay, I have another one like that I wanted to do with you. I think it's a greater than problem. So the other one I wanted to do with you is the absolute value of 6 minus 4n is greater than 60. Okay, so now we're going to do a greater than problem. If it's greater than, do I just put the inequality over here and make it negative 60 over here? No, I do it or. I flip and switch this. So I write the absolute value part the same, 6 minus 4n, but then I flip the greater than, make it less than, and I make this positive 60, negative 60. And you put an or in, you have to put that or there. It's this or that. And because it's or, the inequalities are supposed to go in opposite direction, the shading. We'll see if it does or not, okay, when we finish the problem. Okay, so let's, to solve this, we want a minus 6, right? Minus 6, boom. And I get negative 4n when I bring this down. There's still a negative in front. That negative does not go away just because there's absolute values. Okay, and 60 minus 6 is greater than 54. I'm thinking of something right now, a side note, and I don't know, just popped into my head really quickly, guys. A side note, if there's a number in front of an absolute value like this, okay, you are not allowed to distribute this number. It does mean 2 times the absolute value, but never distribute over absolute value, okay? That's not allowed. So you are not allowed to do this. You're allowed to do if there's no absolute value. If it's 2 times x minus 2, then yeah, use the distributive property. But if there's an absolute value, you have to evaluate this, the absolute value first, and then multiply by 2 after. So never do this, okay? That just popped into my head for this problem right here. I don't know why, but it did. Now we're gonna divide by -4. What happens when you divide by a negative? And you have to remember to do this. You have to flip the inequality sign. See, I flipped it the other way. It was greater than, now it's less than. 55 divided by 4 is -13.5, because I put that in my calculator earlier. Or, now we have to do this part, subtract 6 again, but this time we're subtracting 6 from -60, which gives me -66 over here this time instead of 54. We still have that -4n. We're going to divide by -4. Divide by -4. When you divide by that negative, you got to flip the inequality sign the other way. Anytime you divide by or multiply by a negative, which we haven't multiplied a lot yet. 66 divided by 4 is 16.5, positive 16.5. 16.5. So here are our 2 answers. Let's make a number line. You always need to make a number line, right, for your solution. You always need to graph your solution. So -13.5 is between -14 and -13. I need to see that you know where they are, so you need to put both. We're going to put an open circle here, halfway in between 13 and 14. We're going to shade, less than. These should go in the opposite direction. So yeah, this way to the left, or greater than 16.5. So let's put 0 in the middle, and here's 16, here's 17, and it's halfway between those 2 numbers. So open circle, shading to the right, right? Shading to the right. So that's what our graph looks like. All the numbers to the left of -13.5 and all the numbers to the right. One other thing we should do is to test a point. So let me show you how to test 3 points. If I test a point to the left, let's pick a point to the left. Let's pick -14, right? I know -14 or -15. If I plug in -14 in here, it should work. So let's plug -14 in here to test if our shading is correct. So absolute value of 6 minus 4 times -14, absolute value, is that greater than 60? Okay, 4 times 14, I put that in my calculator. 4 times 14 is 56, so -4 times -14 is positive 56, so 6 plus 56, absolute value of that. This is 62, absolute value of 62 is greater than 60. Is that true? I hope so. 62 is greater than 60, so it worked. So when I plug this in, it tells me that is the solution. It should be in the shaded area. If I try 0, should it work? Let's try 0 right here. Okay, so I'm gonna erase this stuff so I have room here. I'm gonna try 0. So I plug in 0 into here. Get my pen back. Okay, 6 minus 4 times 0. Absolute value of that is greater than 60. I don't think this is going to be greater than 60 because this is 6 minus 0. 6 minus 0 is absolute value of 6. So 6 is greater than 60? No way. That doesn't work. So it means this is not a solution, which is good because it's not shaded. Okay. Lastly, we should try, erase this stuff. We should try a point on the right side of the shading. So if I pick 17 or I'm going to pick 20 20 is over here, right? I want a nice easy number to pick. So I'm going to put 20 in here. Absolute value of 6 minus 4 times 20 is greater than 60. Okay. 4 times 20 is negative 80. So 6 minus 80 is negative 74. But I'm going to take the absolute value of negative 74. That's positive 74. Is that greater than 60? Yes. So this should be 20 should be a part of our shaded area, and it is. So that is one way you can test your answer, is you can pick a point that's not in the shaded area and test it, or pick points that are, and pick both points in the shaded area and test them. So we had to test 3 points into the original equation. I didn't bother with this, just in the original equation right there. Okay, guys. So let me pause my recording here.